Hello, everybody. Welcome to Lab 2, Soils and Soil Mapping. Hopefully you guys all did great on the quiz last week. Hopefully you were all able to find it and take it. There were no technological issues there. If you had any trouble, make sure to reach out to me and sort of explain the situation so I can try and help you for this coming week. Because again, those sorts of assignments are going to happen pretty much every week. Nobody came to my office hours or anything, so hopefully that means the whole lab went well and there weren't any trouble there. So again, we're going to sort of start this week's lab with a very quick information overview for the different things that you might want to know going into the lab. So I've got a little PowerPoint made that I'll go ahead and pull up. So once again, this is Lab 2, Soils and Soil Mapping. So first, let's cover really the basics of soil texture and structure. Soil texture describes the size of individual soil grains, and soil structure is how soil particles are cemented or bound together into heads or aggregates by physical, chemical, and biological processes. It's important to know that soil structure describes larger sized features than soil texture. So looking at soil texture, there are three true soil sizes: clay, which is the smallest, silt, and sand, which is the largest. Now here is a sort of diagram or tool called the soil texture triangle. And this is going to be important for this week's lab. So I'm going to very briefly go over how to use it and what you can do with it. So you can see here, looking at my cursor, that you have these sort of 3% axes that form the triangle: the percent clay, the percent silt, and the percent sand. And so what you can do with this by following along sort of the lines and the space in between them is, from a type of soil, you can approximate the percent compositions of the soil texture, and from the percent compositions, you can describe the soil type. And so just as a very brief example of each of those, let's say that someone tests my soil and tells me that I have in my yard silty clay loam. And so knowing that, if I look here in this area, I can approximate that that soil is likely 30% clay, 60% silt, and about 10% sand. And then the second thing you can do with these triangles is, if you're given those compositions, you can trace it back to a soil type. So let's say that I test my soil and find out that it's 40% silt. So I'm going to come here and I'm going to see that it's 40% silt. So I'm going to be following this line, and then let's say that same soil is also 60% clay. Oh, sorry, not 60% clay. Let's say that same soil, if that soil is 60% clay, then they're going to intersect here, and it's going to be sort of on the crossroads of clay and silty clay. But if I test that soil and it's 30% clay, then I can follow the 40% down to the 30% here, and I'll see that where that intersects is clay loam. And I would also have known that it was 30% sand. So looking at that intersection, you have these. But you can see that I only actually needed two values to find that location. And so it's important to know that that third value in general is going to just be a check. So if I know it's 40% silt, I know it's 30% clay, then by process of elimination, I know it's 30% sand. And so I can check just to make sure when I follow those two lines that those things line up. All right, and it's important, what the confusion I had earlier is that it can be a little hard to follow the angles of the lines. And so when I was trying to read the thing for the clay loam, I was following this 60% here, whereas the horizontal lines actually apply to the clay, this angle diagonal applied to the sand, and this angle diagonal applied to the silt. So just keep that in mind as you're going through the soil texture triangle and as you're going through the lab this week. Quickly going over porosity and permeability. Pores are the spaces between soil particles. Porosity represents the volume of pore space divided by the volume of the soil sample, and permeability is the ease with which water moves through the soil. It's important to know that porosity and permeability are not interchangeable terms. And finally, and I really want to stress this for this week, especially because it wasn't as important last week, make sure to write down your answers during the lab and to have those available for you on the quiz. There are going to be questions on the quiz that you might not be able to figure out without information from the lab. So you're going to want to have those answers written down and available for you at the time. All right, so now we're going to switch over and go look through the lab itself. So again, it's going to look a lot like last week's lab. This is lab 2, soils and soil mapping. It'll provide some background information on soil properties and the importance of soil texture and structure. Make sure you read through that, but I've covered a lot of the highlights of that in the PowerPoint just before. And so for today's lab, there are 3 different activities that involve soils and soil mapping. The first activity is going to be using the soil texture triangle. So if my explanation didn't make sense and you still have questions, there's a YouTube link right here. You can go watch that video and that will explain soil texture triangles in a little bit of a different way. And hopefully that'll help. And of course, if you still have questions after that, please, my Zoom office hours, email, feel free to reach out. So after you watch that video, or if you feel like you have a good grasp right now, you can go and answer these 4 questions using the soil texture triangle up here, sort of walking through it in the ways I just did in the PowerPoint. After that, you're going to have a second activity, which is running soil drainage experiments. So for this, you're going to go to this link, which brings you to this website here. Make sure to ignore these instructions over here on the left side of the screen. Those go way more in depth than what we're going to do for this lab. So if you end up doing a bunch of that stuff, you're going to just be wasting your time and doing a lot of math. So what you can do here is, and this website is going to make really annoying noises, so you might want to mute your computer when you're doing this stuff. But so what you can do is you can come up here and change the compositions of your soil to have different compositions. And then what I'm going to do is run through just the first one in this table, because that's what you're going to be filling out, is this table on these information here. So you look at the first one. So let's say we want to look at heavy clay, and it tells us here that that's 100% clay. But on the other ones, you're going to need to write down what those percents are given here. So if we want heavy clay, that's heavy sand. So if we want heavy clay, right here, we're going to first test the soil. And then what we're actually testing it for is to see how much water you can add before water drains through. And so we're going to pour the water, and we find out that 58 milliliters of water were poured before any drained through. So what you need to do for each of these is write the amount of water needed to drain and the percents given here for the water samples, for the soil samples as you do them. You're going to go through that. Oh, and you can, when you want to move on to the next sample, you just hit reset, and then you move it to your next soil sample type. So smaller numbers, like less than 40 milliliters of water, represent low pore space and high infiltration, while larger numbers greater than 50 milliliters of water represent high pore space and low infiltration. So you're going to use all of this information and the table you filled out to answer these questions after you've run those 9 soil samples. And then we have lab activity 3. And so what you're going to do is click this link here, which is going to take you to the soil mapping part of today's lab. And so I'll walk you through sort of the basics of how to use this website in case you have any questions, and you can come back and check out this video if you have any concerns while you're doing it. Or of course, again, reach out to me, come to my Zoom office hours, and I can hopefully help you out. So when you load the website, it's going to look like this. So you're going to go to the menu, and you want to zoom to a location, And the lab provides you here these latitude and longitude points, which are going to be near the visitor center in Congaree National Park. You can see that location here. And so now we're going to walk through sort of the basics of what this website offers. So if you click a spot in this PS area, what you can see are sort of a bunch of data broadly describing the soil in the area. So you have the soil's name, what it's composed of, things like available water storage, flood frequency. There's a lot of information here. And the lab text itself sort of runs through this information in more depth than I'm going to. So make sure to read through these sort of identifying parts of what each thing in this means. And then within here, you can see that it shows you the map unit composition of the different soil types. So the dominant soil here is %, and we can click that to get a look at the soil profile. And then there are various other options. You can look at the organic matter, % by depth, clay, sand, pH. There are all kinds of options here that you can explore. It's also important to know that you can close this down, look over at soil taxonomy, like soil order, which I believe you all went over in lecture. Hydraulic and erosion readings. So these are forest productivity. So these are sort of the measures you're going to look through as you conduct this lab activity. And so with all of that in mind, you're going to be looking at 3 specific locations in Congaree National Park. Those latitude and longitude points are given here. So you'll want to close out of this and zoom to those specific locations that are given. So the first one is this AEC, which is Ailey soil. So you're going to go through for each of these 3 locations at those latitude and longitude points. You're going to fill out this table. These top measures here are come from this section here. So the sort of map unit composition, map unit data. And then the bottom section here is going to be describing the dominant soil type, which you get to by clicking here and looking through things like the soil profile in these various measures, and then these other drop-down menus. Once you fill out this table, which again, you're going to want to have access to on the quiz, you're going to want to answer these questions too. And again, some of these questions may come back up on the quiz, so you're going to want those answers available to you. Those are all the basics of the lab for this week and the activities. Your grade, again, you're going to have a quiz. It's going to be due this coming Sunday at 11:59 p.m. Make sure to get it done. If you have any issues, make sure to reach out to me. And my Zoom office hours this week are going to be the same as the previous 2 weeks with the same links again. If you have any questions, if you have any issues, please reach out to me. Have a great week, everybody, and thank you so much.